Assalamualaikum semua. Selamat tengah hari.
Assalamualaikum doktor.
Waalaikumsalam doktor.
Boleh nampak ke skrin saya?
Yes doktor.
Ya doktor.
Boleh Okey. Okay guys, I think we should start. We have like 10 questions. So I'm gonna start with the question number 1. Okay, kita ada siapa untuk soalan pertama? Maybe Aiman ada? Aiman, you boleh, could you please read out the question first? Mungkin boleh baca soalan dulu.
What quantities appear in the first law of thermodynamics?
Okay, quantities appear in the first law. Okay, apa dia What do you think, Aiman?
What heat?
Tak dengar lah Aiman. Banyak sangat gangguan kat belakang you tu.
Oh, sorry, ada construction ada.
I see. Tak apalah, saya tanya Aimi. Aimi Iwani ada?
Yes doktor.
Okay, Aimi, what do you think of this? The first one. First question.
C. Work, heat and thermal
Work,
energy.
heat, thermal energy. Okay. Pasti Okay, betul ni. Anissa, boleh confirmkan jawapan ni? Anissa, what do you think? Do you think that the answer is C?
I think yes.
Yeah.
Work, heat and thermal energy.
Okay, what about Anissa yang lagi satu? Setuju tak Anissa Osman? Tadi Anissa
Saya
Natasha.
yang jawab tadi.
Oh,
Anissa
kamu yang
Osman.
jawab.
Okay.
Okay. Saya tanya Anissa Natasha pula. Anissa Natasha, are you there? Azian ada? Azian?
Ya ada.
Azian, what do you think?
Sama juga sih. Betul.
Sama Okay, we agree that the answer for question number 1, quantities appear in the first law of thermodynamics should be work, heat, and thermal energy. Okay, thank you very much. Okay, let's go to question number 2. Okay. Question number 2. Chan Liang Wai, boleh baca soalan? Could you please read out the question first? Clarissa?
Yeah.
Clarissa, boleh tolong saya baca soalan?
What was the original unit for measuring heat?
Okay, what's the original unit to measure heat?
I would like to answer E, calorie.
Calorie. What about joule? Can we actually measure heat with joule?
Can, but then I get it'll be a lot of like decimals for it.
Okay, so the original unit to measure heat is calorie. Saya tanya soalan kepada yang lain. Siapa lagi kawan-kawan you? Siapa lagi? Alicia Chong?
My answer is joule. C.
Your answer is joule.
Yeah.
You don't agree with calorie?
Yeah. I mean, like, joule is the first thing that came up to my mind, so.
I see. Okay, what about Farah Aisha?
Yes, doctor.
Which one?
My
Joule
answer
or
is
calorie? E, calorie. Everyone else? Do you think that the original unit to measure heat is calorie or joule? Which one comes first? Kilocalorie or kilojoule? Joule. Agree? Everyone else?
Calorie to measure energy.
Yeah. Joule or calorie? Can we agree that it is joule? Can we agree that it is calorie?
I think it's calorie because we base on the meaning of the unit.
Okay, calorie. Orang lain setuju tak?
I think calorie is using to measure the thermal energy.
Mm-hmm. Because we're talking about the
Not
original units. Remember, guys, original units. Maybe of course, we can both actually use joule and calorie, but which one is the original units? It's not bukan salah, bukan tak betul, tapi which one is the original? Itu soalan dia. Setuju? Calorie? Setuju? Joule?
Yes, Doctor.
E, yeah?
Yes, doctor.
All right. Okay, I'll just move. Calorie, yeah? Okay, thank you. Let's move on to question number 3. Question number 3. Okay, who's going to read question number 3? Fatin Arina? Do we have Fatin Arina here?
Yes, doctor.
Okay, Fatin, why don't you read it out for us, please?
Heat is
Okay, heat is defined as...
I answer B.
Tak dengar lah, kuat sikit, boleh tak?
D.
B,
D.
D,
Ah,
both A and B.
yes.
Okay, itu jawapan kawan kamu. Fatin kata B. What about Fazira?
Hello, Doctor.
Do you agree with Fatin?
I'm afraid that I disagree.
Okay.
I choose the energy that moves from a hotter object to a colder object
Mhm. I see. So you said that it is B, yeah?
because the answer for A is for
Yeah.
thermal energy definition.
I see. That's the
Yeah.
thermal energy. Yeah. Okay.
Okay, thank
What
you.
about? Okay. Thank you, Fazira. Fong Ding An.
Yes, I'll also choose B.
You said it is B, yeah? The energy that moves from a hotter object to a colder object. Go. Oh, sorry. Question number 3 sampai siapa Fazira Tadi Fazira saya dah tanya ke?
Sudah, Doktor.
Dah Siapa yang saya belum tanya lagi? Farid belum?
Ya, Doktor.
Farid, what do you think?
Saya pilih D.
You pilih D. Both A and B.
Both A and B.
Okay guys. Now we have two options. Seorang kawan you kata A and B means that heat is the amount of thermal energy in an object. Betul ke? How do you find heat? Is heat a thermal energy in an object? Amount of thermal energy in an object? Betul tak? Boleh tak kita kata macam tu? B betul lah. B memang betul. B is correct. But what about A? Can we actually say that heat is the amount of thermal energy in any object?
Tak boleh.
Tak boleh. Kenapa?
Inaccurate.
Thermal tu bukan about heat je. I guess.
Okay, what is it? What
Boleh.
is the definition?
I think B. B is the safer.
Okay, tadi discussion dia adalah you kata heat is not just about thermal energy. Macam mana kita define?
I mean, thermal is not about heat only.
Okay.
Thermal is not about heat only.
It's
about
not just
kinetic,
about-
potential.
I see. So agree ke yang lain-lain? The answer should be B for this question.
Yes, Doctor.
Yes, Doctor.
Agree.
Alright, so we've come to a conclusion, yeah? Okay, let's move on to question number 4. Okay, who's gonna do number 4? Go Yu Yen.
Yes, doctor.
Here go. Please read out the question first.
Okay. In an endergonic reaction, my answer is A. The reactant contain less free energy than the products.
In an endergonic reaction, your answer is A.
Yeah.
Okay. The reactants contain less free energy than the product. So we're talking about endergonic. Endergonic is about, is it releasing or absorbing energy?
Absorbing energy.
Absorbing. What about the second option? Okay, saya tanya, tadi saya dah tanya siapa? Ko kan? Now I'm gonna ask Haida.
Yes, doctor.
Okay, Haida, what do you think of the second option, B?
I think
Cuba
the
bacakan. Cuba
B,
bacakan.
the reactant contain more free energy than the product. That means it's related to exogenic reaction.
Exothermic.
Yeah, sorry, yeah.
Okay, so tak betul.
Yeah, tak betul.
Tak betul Okey, saya tanya Julia pula lah. Julia ada? Julia Amira? Julia there?
Yes, doctor.
Julia, read out the
Yes, sir.
option, this third option, C.
No activation energy is required.
Is it true for endergonic reaction?
No.
Tak betul.
Endergonic reaction require energy. That's why the reactant contains less energy than the products. They
Okay.
absorb energy.
They absorb energy, yeah?
Yeah.
Okay, thank you. I'm gonna ask Kwek Jin.
Hi, doctor.
Hi, what about the fourth option, B? Cuba bacakan jawapan tu.
Catalysis cannot occur.
Betul ke in an organic reaction?
Salah. Kerana because of endogen reaction require enzyme to do catalysis.
Okay, because we're talking about biological system, yeah?
Yes.
Okay, satu lagi option, Lau Ngahi.
Yes,
Lau
doctor.
ada? Hi Lau.
Yes.
Apa
Hi,
kita punya
doctor.
option yang last tu? Substrates what? Bacakan.
Substrate outnumber enzymes.
Substrates outnumber enzyme. Betul ke?
No.
No. So, setuju jawapannya apa?
A.
So the answer for question number 4 is A. In an anorganic reaction, the reactants contain less free energy than the products. Okay, kacang goreng je kan? Okay, let's move on to question number 5. We have Li Wei Yi.
Yes, doctor.
Okay, Li, please read out the question first.
Sure. Okay. The energy of random molecular motion is called A. Heat.
Heat. The energy of random molecular motion is called heat. Okay, saya tanya apa kawan you? Lim Ting.
Yes.
What about B?
I don't think it's B.
You don't think it's B? Random molecular motion. It's not free energy, yeah?
No.
What is free energy actually? Apa definition kita hari itu?
Free energy is the energy available to do work in a system.
Yes, available energy to do work in a system. Okay, what about option C? Kita tanya Mira Natasha.
Yes, doctor.
Is it enthalpy? What is enthalpy actually?
Sum of systems internal energy and product.
Internal energy and products. Okay. Who's next? Adli?
Yes, doctor.
What is potential energy?
It relates to an object, the resting place, and has a potential to associate with restoring forces.
Okay, so random molecular motion bukan potential energy.
No.
Tak betul.
Tak.
Betul Okay, saya nak tanya Ainul Hakimi last.
Yes, doctor.
Okay, activation energy is, what is activation energy? Apa yang kita faham tentang activation energy so far?
The amount of energy that is required to activate chemical reaction.
Activation, yeah. Okay, to activate something. Okay, thank you very much. So, guys, so question number 5, the answer is
A.
Heat. Is it heat? You guys agree heat?
Yes.
Ada orang jawapan lain? Tak ada eh? Okay, I'll move on to question number 6. Question number 6, we'll start with Muhammad Izzan. Izzan ada?
Yes, betul.
Hai Zan, baca soalan Zan.
The energy available to do work in system is called.
The energy available, okay. The answer? What's the answer?
Free energy.
Free energy.
Yeah.
The energy available to do work in the system is called, dia kata free energy. Betul ke kawan-kawan lain? People in the same group? Siapa? People in the same group?
Betul.
Betul ke? Siapa people in the same group?
Saya.
Najib, Saad, lagi? Naja dengan Eng.
Ya, betul.
You guys agree?
Yes, Doctor.
Yes.
Senang je kan ni, kacang goreng je. Okay, let's move on to the second law of thermodynamics. Okay, ni dia kena fikir sikit lah. Okay, who's doing this? Is it Nur Atira? Nur Atira ada? Nur Atira, Nur Laila, Nur Azmira. Siapa lagi? Nur Farisa, Nur Fatin. Laila ada? We have Laila?
Yes, Doctor.
Laila, tolong bacakan soalan kita, Laila.
Yes, okay. So which of the following situations are related to the main focus of the study of thermodynamics?
Okay. The study of thermodynamics. What do you think? What's your answer?
I think it's about storing the energy and converting the stored energy and determining the energy loss from the system. Basically A, B, and C.
So A, B, and C. So you think it's A, B, and C.
Yeah.
Okay, Laila kata jawapan dia A, B, C. Apa kata Alia? Alia, what
Hi,
do you think?
Doctor.
Hi.
I have the same answer.
The same answer.
Yeah.
We have the same answer. What about D?
Because that's not the main focus, I guess. Because
That's not the main focus.
yeah, it could be like a side effect of like thermodynamics. Like
okay, but you think that it D is not that important lah dalam yang ni, dalam point ni.
yeah, it's not the main focus. Yeah.
All right. What about Farisa ada?
Yes, Doctor.
Farisa, what's your answer?
Same as tables.
Same as other people.
Laila, yeah.
Okay, A, B, C. It's about, okay, nak tanya orang terakhir. Fatin Amira?
Yes, Doctor.
Answer?
Same as them, but I choose C.
You choose only C.
Yeah.
You have only one answer.
I think determining this energy loss from the system.
It's just about determining energy loss. Soalan dia kata, which of the following situations are related to the main focus of thermodynamics, the study of thermodynamics. So thermodynamics is about energy storage. Thermodynamics is about, apa lagi? Is it about storing energy? Is it about converting energy? And is it about converting? And energy conversion. Betul, energy conversion. And energy conversion, energy storage, energy loss. Boleh tak kita kata A, B, C ataupun just A ataupun B ataupun C saja? What do you think, the rest of you? Kita dah bincangkan tentang thermodynamics first law and second law. So apa sebenarnya fokus thermodynamics ni? What is the main things that we are actually looking at kalau kita bincang pasal thermodynamics? Do you guys agree with A, B, and C, or you have only like one particular answer for this question?
A, B, and C.
You think that it's A, B, and C? Do we all agree on this? Boleh tak kita kata A, B, and C? Main focus?
Uh, can, Doctor.
Boleh?
Boleh.
Ada yang membantah kata objection. Tak setuju langsung.
Tak ada.
Tak ada. Okay, kalau tak ada, kita move on A, B and C Okay, next question. Siapa yang buat ni soalan ni? Who's doing this? Who's first on the list? Nur Hazwani.
Yes,
Hazwani.
Doctor.
Okay, Hazwani. What's the bacakan soalan dia, Hazwani?
If heat is added to a system and the temperature of a system increase without knowing anything else, which form of energy will definitely increase?
Panjang ni. Apa jawapan dia? What's the answer? Jawapan dia?
So my answer is A, the kinetic energy of the system.
Kinetic energy of the system.
Yes.
Okay, saya tanya Wahida pula. Wahida Damuri ada?
Ada, Doktor.
Okay, Wahida, what do you think of this question?
I choose the
Sorry.
internal energy of the
Semula
system.
Yeah, the internal energy.
Huh?
Apa jawapannya tadi?
I choose D, the internal energy of the system.
The internal energy of the system. Okay, tadi jawapan kawan kamu tadi apa? B Potential?
A. I
A.
think A.
Tadi kawan kata kinetic Okay, what about Yohanis pula? Yohanis, what do you think? What's your answer, Yohanis?
I agree with Rafika. My answer is
Tak dengar Yohanis, ulang balik.
D.
D, internal.
Yes.
Okay, dua orang internal. Siapa lagi? Nur Farahin.
Yes, Doctor.
Farahin, what's your answer?
My answer is also D, the internal energy.
Internal. Okay, lagi seorang, Hanisa. Hanisa ada. Do we have Hanisa?
Yes, Doctor.
Hanisa, what's your answer?
D, the internal energy.
The internal, okay. The question says, heat is added to a system, temperature increases, without knowing anything else, which form of energy will be definitely increased? Which form of energy will increase? Internal ataupun potential?
Internal, Doctor.
Internal, right?
Yes. Yes.
Alright. Potential is tak tepat jawapan tu. In this case, we're talking about internal energy, including all the molecular energy in the system. Okay, I'll move on to the next question. Siapa baca soalan ni? Who's going to read this out? Nurul Afika ke? Is it Nurul Afika? Nurul Afika ada tak? Sekejap saya... Oh, sepatutnya bukan macam tu kan? Dia punya urutan dia. Sorry, tak apalah. Because we're discussing this. Mana tadi? Okay, number 2. Okay. Siapa kan nak baca ni soalan ni? Saya pusing je lah Okay. Nurul Afika tak ada? Muhammad Asman? Nurul Diana?
Yes, Doctor.
Okay, Afika. Boleh bacakan soalan? Boleh bacakan soalan dia? Bacakan soalan dia. Sorry. Next question, sorry. Okay. Yeah.
Which statement best describe the concept of a system? My answer is A, the subject of the analysis.
Betul.
A.
How do we describe
the subject of the analysis?
System? The subject, bukan object. Bukan. Is it not about a fluid solid mixture? Is it about an object that radiates heat into its environment? Can we agree with A? The subject of the analysis. Setuju semua? Okay, tak ada masalah. Ini simple je soalannya. Alright.
Yes, sir.
Next question. Siapa yang baca soalan ni? Diana. Nurul Diana. Hai Nurul Diana.
Ya,
Apa
doktor.
nak baca soalan?
Okay. Consider a refrigerator in a kitchen. Take the refrigerator and everything in it to be our system. Which best describes the system surroundings? My answer is A. All of the air in the kitchen.
All of the air in the kitchen. We're talking about a fridge in the kitchen. Take the fridge and everything inside it to be our system. What is the surrounding? The question says, what is the surrounding? You said all of the air in the kitchen. All of the air in the kitchen. Maksudnya selain daripada fridge. Saya tanya, okay. Saya tanya Nurul Hafazah. Hafazah ada? Hafazah, are you with us? Nurul Liana?
I think it's Nurul Jannah.
Sorry, Jannah. Sorry, Jannah. Lalu confused namanya. Okay, Jannah, what do you think?
My answer is all of the air in the kitchen, but I'm confused with the everything in the universe external to the system also.
Everything in the universe external to the system.
Yeah.
Because we're talking about a kitchen, right?
Yes.
So it's just only think of just the kitchen.
Oh, okay. So the kitchen. So we'll focus on in the kitchen je lah.
Yeah, kalau kita fikir satu dunia, besarlah sikit kan?
Okay, so that means all of the air in the kitchen is surroundings lah. Is the system surroundings lah.
STA, yeah. Okay, thank you very much.
Okay.
Okay, next question. Ong Tanasilan. Hai Ong. Ada tak ni Ong ni? Ada Ong ke tak ada Ong ni? Ong tak ada ke? Ong Tanasilan, are you with us? Okay, tak apa, saya tanya Rachel. Rachel Kirtina.
Yes, Doctor.
Hi Rachel.
Hi, Doctor.
Okay, Rachel, please bacakan soalan Rachel.
Okay. Consider a refrigerator in a kitchen. Take the refrigerator and everything.
Hey, sorry. The next question. Betul tak? Ni next question ke?
Yes.
Oh, sorry. Okay. Go on. Sorry.
Okay. Take the refrigerator and everything in it to be our system, which best describe the system's boundary.
Boundary. What is the boundary?
My answer will be B, the thin region separating the system from everything else.
Okay. What about all the air in the kitchen?
Just now, the previous question, it like other than system, everything else is all of the air in the kitchen.
So all of the air in the kitchen is just surrounding, right?
Yes.
What about the air inside the fridge? No.
It also includes in the system.
The outer walls of the fridge? It's not necessarily means it's just a wall, yeah? So it's the thin region separating the system. Okay, answer B. Okay, next question. Who's doing next question? Roy?
Hi.
Hi Roy. Macam belum makan je.
Tak lah, dah makan dah.
Okay Roy, read out the question please.
Which of the following statements are true? My answer is C. A system cannot be both closed and isolated.
Which of the following are true? Maksudnya ada satu je yang betul. A closed system is necessarily an isolated system. Betul ke? A closed system is necessarily an isolated system.
Tak.
Tak.
Kalau closed system tak semestinya kena isolate kan.
Okay. What is, apa maksud closed system? Paling senang lah.
Tak ada energy exchange.
Tak ada exchange. Okay. An open system?
Exchange berlaku constantly.
Constantly. Okay. What about D? The concept of closed and isolated in regards to a system are independent concept. The concept of closed and isolated in regards to a system are independent concept.
That one, I feel confused a little.
You're confused. A system cannot be both. Okay, what about the rest of you? What do you think? Kita tanya siapa Let me ask Siti Shahida. Syahida ada Syahida? Siti Syahida. Tak ada Macam mana tadi saya nampak dia? Okay, tak apalah, saya tanya Sureka lah.
Doctor, my answer is D. The concept of closed and isolated in regards to a system are independent concept. That means it can only either closed system and isolated system are two different things and they do not depend on each other.
They do not depend on each other
Yeah.
So tadi siapa cakap tadi? Roy kata C. A system cannot be both closed and isolated. Betul ke statement ni? Can a system be both, cannot be both?
Physics is shit.
What do you think? Boleh tak? Is this true? Cannot be both closed and isolated. Sureka setuju ke?
No, I think my answer is I don't know. I think that C and D are like almost the same meaning.
Almost C and D. Okay, siapa saya tanya kawan you. Susin Raj.
Yes, doctor.
What do you think?
Doctor, my answer would be A, doctor. A closed system is necessarily an isolated system.
Why? Why do you say that? Why do you say a closed system is necessarily mesti an isolated system? It must be an isolated system.
Because a closed system can be isolated, but an isolated system can't be closed.
Okay, saya nak tanya yang lain-lain, kawan-kawan yang lain. The rest of you? Any other opinions? Ada pelbagai jawapan kat sini. We're talking about which of the following statements are true. Maybe betul, ada 2-3 yang betul. Tak semestinya satu je yang betul kat sini. Could be more than one answers here. Okay, kita tengok satu-satu. A closed system is necessarily an isolated system. Betul ke tadi yang kawan you cakap, Ras sebut tadi?
Salah.
Salah?
No, doctor.
No. Okay, dah ada cakap salah tu. Okay, lagi? Ada yang cakap betul? Betul ke salah ni? You guys?
Salah.
Salah Okay, B. An isolated system is necessarily a closed system. Betul ke? Mesti ke? Dia terbalikkan je kan ayat ni kan? So, boleh tak kita terima B?
No, doctor.
No. Okay. C. A system cannot be both closed and isolated. Tak boleh Boleh ke?
Probably, I think.
Yeah.
True.
Maybe because isolated system too means there's
dia
no
tak
exchange
boleh,
of energy.
dia tak release energy dengan
There's no energy being absorbed into the system and there's no energy going outside.
So no energy exchange
No energy exchange.
Okay, so betul ke salah statement ni?
Probably yes.
Statement tu betul.
Betul, C betul. What about D? Is it independent concepts?
Betul juga.
It's true. Betul lah.
I
True,
think D is true juga.
Okay, so we have two answers for question number 6 kat sini. C and D. Do we agree with this?
Yes, Doctor.
Okay,
Yes,
we'll move
Doctor.
on ya. Okay, siapa nak baca soalan ni? Sharina. Sharina?
Yes,
Sharina
Doctor.
binti Sharina. Okay, Sharina. Which of the following? Bacakan.
Yeah.
Number 7.
Which of the following is not an extensive property? My
Extensive
answer
properties ni apa?
is
Okay, jawapan dia.
extensive property.
Extensive.
Kinetic energy,
Kinetic
density, and momentum.
Momentum.
Yeah,
A,
kinetic
B,
energy.
and D.
A, B, and C.
A, B, and C. Density atau mass?
A, B, and sekejap. Oh, A, B, and D.
A, B, D, yeah? Okay, your
Density.
answer is A, B, D. Density, yeah? Teo Siu Liu?
Yes, Doctor. My answer.
Teo, what do you think? What do you think? Jawapannya apa?
D, density.
D, density. What about kinetic energy and momentum? Look at the units.
Units.
The units. Remember when we talk about intensive and extensive properties, you have to look at the definition of it. Extensive is about.
I think the kinetic energy and the momentum is under the extensive property.
Extensive. A and B. What about D?
No, not under.
No. You don't think that density is extensive?
Yeah.
Okay, siapa lagi saya nak tanya? Who else? To?
Yes, Doctor. I
What do you
also
think?
agree with D, density. As
Density.
it is the intensive.
Not kinetic.
Yes.
Kinetic dengan mass tak termasuk dengan momentum.
Tak.
Tak. Why do you think so? Kenapa density saja?
Because density is the intensive property which not dependent on the mass and size.
Oh, it is not depending on mass and size. That's the definition of extensive?
Yes.
Betul. Okay, so jawapan you adalah density, ya. Orang lain? Other guys? Other people?
Same answer, Doctor.
Same answer? Can we agree with D? Density?
Yes.
Yes.
Yes, Doctor.
Thank you very
Yes,
much.
Doctor.
Okay, Wong.
Yes, Doctor.
Bacakan soalan yang seterusnya. The next question.
Okay. Which of the following is not an intensive property?
Intensive properties. Answer?
My answer is B, volume.
Volume. Okay, and intensive means, definition intensive? Easy one.
Intensive property is the independent of mass or size of the system.
Independent of mass and size of the system.
Yes.
So your answer is temperature.
No, B, volume.
B, volume. Volume. Setuju ke yang lain? It's not velocity, it's not volume. Pressure, temperature. Velocity, pressure, temperature. Only volume.
Yes, Doctor.
What about pressure? Pressure tak masuk ke?
Pressure is intensive property.
Extensive.
Intensive.
Yeah, intensive. It's an
Intensive.
intensive. Yeah,
So yang jawapan yang salah kat sini adalah
volume B.
volume saja. Yang lain-lain tu betul So
Yep.
we have velocity, pressure, temperature are all intensive properties Okay, thank you very much. We'll move on to the soalan yang seterusnya. Zaidatul. Azwa lah. Panggil Azwa.
Yes, Doctor.
Okay. Bacakan soalan dulu.
Give an example of biological system and answer the following.
Okay, apa jawapan you untuk satu apa contoh one example of a biological system. Any biological system. Ada banyak kan? Apa jawapan you? Respiratory system.
Yes.
Okay, kalau you jawab respiratory system, is it an open system? Adakah ia sistem yang terbuka?
Yes.
Why do you think so?
Because
Kenapa respiration kita adalah open system?
Because it exchange energy and matter with the surrounding.
Okay. Okay, saya pergi ke kawan kamu sekejap Thank you Azwa. Saya akan patah balik kepada Adimas Adimas, you there? Adimas, kamu ada di situ? Oh, Adimas.
No, Doctor.
Tak ada Adimas tak ada?
No.
Oh, tak ada. Okay. Saya pergi
Doktor,
kepada
doktor.
Aiman lah. Aiman.
Doktor.
Okay, Aiman, you there?
Yes, Doctor.
Okay, let's say we're talking about respiratory system. The next question says, if you heat up the system, kalau kita panaskan sistem respiratory system at a boiling point, what would you expect in terms of entropy at the equilibrium? Okay, kita ada satu sistem nama dia respiratory system. Sekarang ni you panaskan, you boiling it up at a boiling point. What do you mean by boiling up? You're adding heat to the system, right?
Yes.
So when you add heat to the system, what happens to your system?
It's gain more energy.
Okay, then what it becomes? Remember entropy? It's about disorder.
Oh yeah.
Randomness. So what is the expectation here? Bila kita panaskan, jadi apa sistem ni? Okay, saya tanya kawan yang lain pula. Okay, Aimi, Iwani.
Yes, Doctor.
Aimi, what do you think? Kalau you panaskan sistem ni jadi macam mana? What happens to the system in terms of the entropy of the system?
The entropy will increase.
Increase. Okay, itu je ke jawapan dia? What would you expect in terms of entropy at the equilibrium? Apa maksud equilibrium? Bila kita kata at the equilibrium, maksudnya apa? Is the reaction still taking place?
No changes.
No more changes happening. So kat situ apa berlaku? Bila panaskan sistem. Apa kita boleh jawab kat sini? Kita tanya Anissa lah pula. Anissa Natasha. Anissa Natasha ada. Anissa Osman lah. Anissa Natasha dia tengah shopping.
Yes, Doctor.
Okay, Anissa, what do you think?
Equilibrium is the state of the maximum entropy, right?
Right. So, apa pendapat you?
So, if isolated, no further change would occur in entropy.
No further changes.
Because that would violate the second law of thermodynamics.
Okay. Saya tanya kawan yang lain-lain boleh? Guys?
Doctor, how about we say that the high temperature area will transfer the heat energy to low temperature area?
Boleh, tapi because we are talking about sistem kita tadi apa? Respiratory system kan?
Yeah.
So sekarang ni sistem kita sekarang berada di equilibrium. Maksudnya apa? Maksudnya semua temperature sama kan?
Ya.
So ada lagi tak berlaku energy transfer from hotter place to colder place? Tak ada.
No. Yeah.
So apa kita boleh cakap kat sini? What is the conclusion?
The respiratory system is
in terms of entropy, kita cakap pasal entropy dulu. Entropy at equilibrium.
No change in entropy.
No.
Okay, mula-mula you have to explain what happens when you heat it up. When you heat up the system, bila you panaskan sistem jadi apa? And then bila sampai daripada equilibrium jadi apa pada sistem? That's the kind of answer that you should have. Yeah? Boleh? Faham
Faham.
Okay, next one. Azian, bacakan soalan referring to blah blah blah.
Referring to the above question, is it a reversible process?
Okay. Betul ke respiratory system kita ni, is it a reversible system? Is it a reversible process?
Yes.
Yang tadi itulah yang heating up yang dipanaskan tu. Adakah dia reversible process?
Yes.
Yes, you think it is. It is a reversible. Orang lain? Do you guys think that this is reversible? You dah panaskan, lepas tu sejuk balik. Adakah dia, can you actually move this, apa orang kata, balikkan semula kepada original state?
No.
Boleh tak? In respiratory system. Reversible or irreversible?
Irreversible.
Irreversible maksudnya dia tak boleh patah kan? Kalau dia tak boleh balik kepada original yang asal tu. Betul ke macam tu?
Kalau ada equilibrium means dia balik pada dia punya normal state lah.
Betul.
So reversible.
Reversible.
Yeah.
Agree? Reversible?
Agree.
Semua orang setuju?
Reversible.
Yes.
Okay, last question.
Agree.
Saya nak tanya Chan Leong Wai. Chan Leong Wai?
His mic isn't working, doctor.
Oh, tak ada. Clarissa lah.
Okay.
Clarissa,
I think it's,
nak bacakan soalan? Is heating up?
okay. The question asks, is heating up endothermic or exothermic?
Yes.
I think it's endothermic because it's absorbing heat to rise temperature.
Okay. Betul ke kawan-kawan yang lain? Clarissa said heating up is an endothermic.
Yes, sir.
Endothermic means you are
Yes,
adding
doctor.
to the system, yeah? Okay. Last question. Elisha Chung?
Do I read it out, doctor?
Tak ada.
No, I mean, do I read the
Oh,
question?
okay.
or-
Please read out the question first, yeah.
Nutritionists are interested in the use of energy by the human body, and we can consider our own body as a thermodynamic system. Suppose in the course of an experiment, you do 600 kilojoules of work on an exercise bicycle and lose 90 kilojoules of energy as heat. What is the change in your internal energy? Disregard any matter lost by respiration.
Okay. You do an experiment, 600 kilojoule of work. Maknanya you buat exercise, naik bicycle, and then the question says that you lost 90 kilojoule of heat as heat. Maksudnya, when we do exercise, kita berpeluh kan? So when we're sweating, we are orang kata losing energy. So what is this change in your internal energy? What do you think? Apa soalan ni nak tanya sebenarnya? Sebab dia kata kat situ, please disregard any matter lost by respiration. So this is like an apa kita panggil? Is this an open system, closed or isolated system? Ideally.
Closed system.
I think it's
Is
an
it?
open system, Doctor.
It's an open system, right? Sebab dia
Yeah,
boleh keluar kan?
sebab energy
Semua
boleh
boleh keluar.
keluar and dia ada lose energy lah basically. There's an exchange
Okay.
of energy.
So how do we explain the change in our internal energy? Internal energy maksudnya apa? Tadi start dengan 600 and then you lost 90 kilojoule. 90 kilojoule tu hilang. What is the change in your internal energy? Apa perubahan dia? Farah Aisyah? Farid, tolong Farid. Farid Amir.
Saya pun tak pastilah doktor.
Tak pasti, Farid tak pastilah. Kena tanya Fatin Arina lah pula. Fatin, what do you think?
Saya pun tak tahu.
Tak tahu juga.
Tak.
Fatin Nazura, please.
I'm not sure, Doctor. But energy is lost from system, right?
Ya, betul. Apa perubahan di dalam internal energy? Fazira? Fazira ya? Tak ada juga. Fong? What do you think, Fong?
Calculation.
What was that? Say again?
I made a calculation with this question.
Okay, apa kalau you macam ni jawab? Macam mana kita nak jawab soalan ni?
Is it we need to count?
I'm not sure. What do you think? You nak kira ke?
Yeah, I use the calculation.
Okay, then what do you get?
I get 510 kilojoule.
Okay, how do you relate that with your internal energy? Change in your... Ada tak apa-apa berlaku kepada internal energy?
The internal energy is decreasing.
Increasing? Decreasing?
Decrease.
Decreases.
Because
Okay.
it transfer out the decrease by releasing the heat from our body to surrounding.
Okay, so you're saying that internal energy is decreasing.
Yeah.
Okay, thank you. Tak apa, saya tanya Go lah pula. Go, do you agree with Fong? Tadi Fong kan?
Yes, Doctor.
You setuju tak?
For me, it's like negative 690 because there are 600 kilojoule of energy is lost and 90 kilojoule of energy is lost as heat as well.
Okay. So berapa tadi you kata hilang? Sekarang you punya internal energy? Sekarang jadi berapa?
Negative. A total decrease of like 690 kilojoule.
Minus 690 kilojoule. Semakin menarik nampaknya. Haida, do you agree? Jawapan you apa?
My answer is negative 690 kilojoule.
Minus negative 690.
Yes, true.
That's your change
Answer.
in your internal energy. Betul?
Yeah. That's my internal energy fall by 690.
Okay. Orang lain setuju tak dengan jawapan ni? Minus 690 kilojoule.
Setuju, Doktor.
Yes.
Setuju.
Yes, I got the answer same too.
Betul Okay, I think we have answered everything today. Thank you for attending. Nanti kita akan masuk tajuk baru this Wednesday. Betul
Yes.
Okay guys, I think that's it for today.
Okay.
Alright, I'll see you again next time. Bye.
Thank you, Doctor.
Thank you,
Thank
Doctor.
you, Dr.
Thank you,
Brain.
doctor.
Thank you, Doctor.
Thank you,
Thank you, Doctor.
Bye, welcome.